In this question, you're given that y is equal to tan inverse of a cos x minus b sin x by b cos x plus a sin x. You're asked to find the function dy by dx. So inside tan inverse, you have trigonometric function. So let us first try to simplify this. So what I do is a cos x minus b sin x by b cos x plus a sin x. So what I do is I'll divide both numerator and denominator by b cos x. So let us see what happens if I do that. Please remember this question special. So if you divide both, numerator and denominator by b cos x and see what magic happens. So what happens here, you get a by b because cos x gets cancelled minus. So if you divide this by b cos x, b gets cancelled. So sin x by cos x is tan x divided by b cos x and b cos x gets cancelled 1 plus a by b into sin x by cos x is tan x. So a by b minus tan x by 1 plus this. So what I do is now I'll take a substitution. Let a by b is equal to some tan theta. So this looks like tan theta minus tan x by 1 plus tan theta tan x. That is equal to tan of theta minus x. Tan of theta minus x. So this expression, if a by b is equal to tan theta, is tan of theta minus x. So what is tan inverse of tan? These two gets cancelled. So y is nothing but theta minus x. So if you do the back substitution, theta is nothing but so tan a minus tan b by 1 minus tan a tan b is tan of a minus b. So theta is tan inverse of a by b minus x. As you can see, this is a constant. So if you do the differentiation dy by dx, you get 0 minus 1. So the value of dy by dx is always equal to minus